Have you ever wondered how rockets, those colossal structures of metal and fire, manage to break free from Earth's gravitational pull and venture into the vastness of space? To the uninitiated, it might appear as a spectacle of fire and thunder, a display of sheer power. But behind the spectacle lies an intricate dance of physics and engineering. It's a tale of human ingenuity, of turning the impossible into reality. These towering marvels, rockets, are much more than just metal and fire. They are intricate machines, carefully designed and meticulously constructed to do one thing: defeat gravity. And they do this not by brute force, but by harnessing the very laws that hold them down. So, how do these behemoths of steel and flame manage to break free from Earth's pull? What are the principles that guide their creation and operation? How do organizations like ISRO and NASA make space travel possible? Join us on this cosmic journey as we unravel the mysteries of rockets. To understand how rockets work, we need to revisit a fundamental law of physics, Newton's third law of motion. This law, simply put, states that for every action there is an equal and opposite reaction. Let's break this down into more digestible terms. Imagine you're sitting on a spinning office chair and you throw a book across the room. What happens? You move in the opposite direction of the book, right? That's Newton's third law in action. The force you applied to throw the book, the action, resulted in an equal force that pushed you in the opposite direction, the reaction. Now, let's take this principle to the grand stage of space. Picture a rocket standing tall and majestic on the launch pad. At the heart of this engineering marvel is the principle we've just discussed. When the rocket's engines are fired, they expel gas out of the back at high speed. This expulsion of gas is the action. And according to our friend Newton, there has to be an equal and opposite reaction. So, what's the reaction? The rocket is propelled forward with a force equal to that of the gas being expelled backward, but it's not as simple as just throwing gas out of the back. The gas being expelled is a result of a complex process involving the combustion of rocket fuel. This combustion process generates hot, high-pressure gas. The force of this gas rushing out of the back of the rocket provides the thrust needed to overcome the force of gravity and propel the rocket skyward. So in essence, rockets move forward by expelling gas backward with force. But how does this process actually happen in a rocket? Well, that's a tale for another scene. For now, let's bask in the brilliance of Newton's third law and the fundamental principle that makes space exploration possible. At the heart of every rocket lies its engine, a marvel of engineering that brings the principles of physics to life. Every rocket engine, whether designed by ISRO, NASA, or any space agency around the world, operates on a simple yet powerful principle: Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. The action is the expulsion of gas out of the engine, and the reaction is the forward motion of the rocket. At the core of this expulsion is combustion, a fiery reaction that takes place within the engine. Rocket fuel and an oxidizer are combined in a combustion chamber. The fuel, often a type of liquid propellant, is the substance that burns, while the oxidizer, usually a type of gas, is the substance that makes the fuel burn. When ignited, they create a high-pressure and high-temperature gas. This gas is then forcefully expelled out of the engine, creating the thrust that propels the rocket forward. Rocket engines come in various types, each with its own unique characteristics and uses. Some engines, like liquid rocket engines, utilize liquid propellants, offering the advantage of being able to control the thrust by regulating the flow of the propellant. On the other hand, solid rocket engines use solid propellants, which are simpler in design and offer a lot of thrust. But once ignited, they can't be shut down or controlled. There are also hybrid rocket engines that use a combination of liquid and solid propellants, offering the best of both worlds. And then there are ion engines, which use electric power to create thrust, offering high efficiency for long-duration space missions. So, whether it's a mission to the moon, Mars, or beyond, the choice of the engine plays a crucial role, as it determines the rocket's performance, mission capabilities, and overall efficiency. The engine is indeed the heart of the rocket, pumping out gas and propelling the rocket forward. But what about the rest of the rocket? A rocket is more than just its engine. It's a complex structure, each part playing a crucial role in the journey to space. Let's start at the top, the pointy bit, better known as the nose cone. This isn't just for aesthetics. Its sleek, aerodynamic shape helps the rocket cut through the Earth's atmosphere with minimal resistance. Inside, it often houses the payload, which can be anything from scientific instruments to satellites and even astronauts. Below the nose cone, we find the payload fairing, a protective shell that shields the payload from the intense heat and pressure during launch. Once the rocket is out of the Earth's atmosphere, the fairing splits open and falls away, lightening the load for the journey ahead. Next up is the guidance system. This is the rocket's brain, responsible for navigation and control. It makes sure the rocket stays on course and reaches its destination. It's like a sophisticated GPS, but for space. Beneath the guidance system, we find the fuel tanks. These are the rocket's stomach, holding the propellants needed for the engine to burn. Rockets use a lot of fuel, so these tanks are often the largest part of the structure. Finally, we reach the tail section, home to the rocket's engine or engines. This is where the magic happens. The engine burns the propellants, creating a force that propels the rocket upwards, defying gravity. Some rockets have multiple engines for extra power or for maneuverability. Surrounding the rocket are the boosters. These are like the rocket's muscles, providing extra thrust during the initial ascent. They're jettisoned once their fuel is spent, further reducing weight. And let's not forget the thousands of smaller components, screws, wires, valves, and more, each with a specific job. Like a giant jigsaw puzzle, they all fit together to form a functioning rocket. Each part, from the smallest screw to the largest fuel tank, plays a pivotal role in the successful journey of a rocket into space. ISRO and NASA, two giants in space exploration, have been instrumental in our understanding of the cosmos. The Indian Space Research Organization, or ISRO, may be a relative newcomer in the field of space exploration, but its accomplishments are nothing short of remarkable. Ever since its inception in the late 1960s, ISRO has been pushing the boundaries of what's possible. From launching India's first satellite, Aryabhata, on a Russian rocket in 1975, to the Mars orbiter mission, affectionately called Mangalyaan, in 2014, ISRO's journey has been one of innovative solutions and frugal engineering. The Polar Satellite Launch Vehicle, or PSLV, has been ISRO's workhorse, launching numerous satellites into orbit and earning a reputation for its reliability. Across the globe, the National Aeronautics and Space Administration, better known as NASA, has been a beacon of human achievement for over half a century. The Apollo missions of the late 1960s and early 70s, which culminated in Neil Armstrong's historic walk on the moon, are still celebrated as the pinnacle of human exploration. The Space Shuttle program, running from 1981 to 2011, was a testament to reusable spacecraft. Today, the Mars rover missions continue to explore the Red Planet, sending back valuable data for scientists. Both ISRO and NASA have contributed immensely to our understanding of space. Their missions have not only expanded our knowledge of the cosmos, but have also brought about numerous technological advancements. From communication and weather satellites to deep space exploration, the rockets developed by these organizations have been at the forefront of space technology. The journey to space is a testament to human ingenuity and the power of science. It's a journey that begins with a spark in the engine and ends in the stars.